friends, welcome back. In this session we're going to configure Red Hat High Availability Suite. Before this session we have installed all the nodes, uh, we have configured network, storage, yum, we have configured a website. In last session we saw that there was a small S was coming in front of the web page, and the reason behind that was this. I don't know from where this thing came. Maybe during copy I might have pressed S for this. I might have pressed small s, and because of that it was showing over there. So just remove that S and everything works fine. So what I have done, let me close this. I have U-mounted this partition because cluster going to mount all these things. We no need to touch any cluster resource. So let's install the cluster. So for doing that, first we go to manager. And you say yum install Lucy. Lucy is the package which is responsible for the manager service. On the client end, we're going to install when I say client end, I mean cluster nodes. So Lucy is manager service and Ricky is a client service. So we're going to install Ricky on both the nodes. It's going to take some time. This whole service is written in Python. As you can see, it's all Python. So it's a Python based application. Sorry. So it's almost done. It has installed Lucy on the manager, and Ricky also installed on one of the node, I believe on node 1, and it's almost done on node 2 as well. Okay, so it's manager, it's done. What we have to do, check config --list Lucy. Lucy is off. On. And again list it. Yes. So Lucy is on, or Lucy is enabled on system startup. Service Lucy start. And it says that just go to a browser and hit this URL, which is https manager.lab.local:8048. Okay. On the client side, on the cluster node, RHEL is also installed. So check config --list RHEL. That is off on the system startup. We have to make sure this is on the system startup. And service RHEL on. Service RHEL start. And check config --list RHEL. Check config RHEL on. And service RHEL start. Great. So Lucy is started on the manager and RHEL is started on the client node. Nothing much is required after this. Just open your web browser, hit 192.168. In my case is now 15.8084. This certificate is not trusted, and this is the IP address of my manager. So because I don't have hostname configured on my base system, so I have to use IP address. And this is self-signed certificate, so I have to say yes, I trust it. Login as root with the root password. This is the root system user. This is giving a warning stating that this is a graphical interface for high availability add-on, and you make sure that you understand the underlying concept before using it. Yes, I think I know the underlying concept. So let's go ahead, click on manage cluster, create cluster, and just give it a name. I'm giving a name web cluster. Okay. But before that, I'm sorry I forgot one step. What we have to do, we have to say, or we have to set the password for RHEL. Great, and let's do the same thing on second node. I'm not giving a complex password, it's very simple password, and make sure you give the same password on all the cluster nodes. In my case, all the 2 nodes. Okay, so node 1, the password is and add another node. Node 2, use same password, so I need to make sure I'm typing right. Correct. Download all the packages, reboot the node before join, and enable shared storage support. While it's doing this, we can go one of the node and we can say tail -f / var log messages and var log secure. Just want to show you what exactly it does. So create cluster. So it started. Just go to the node 1 and you can see here it's started installing some packages which is required for the cluster services. So this is going to do the same on both the nodes. It's going to take some time for the update. You can see this website. It's going to update you. It's going to take somewhere around 10 to 15 minutes to install the packages on both the nodes. So I'm going to pause this video and we're going to join back once this finished installation of all the packages. Okay, so installations are almost done. Both the nodes has rebooted. So let's take the fresh session and see. Let's wait for this process to finish. Okay, so it's showing the node 1 is perfect. But node 2 is having some problem. Okay, no problem. We will fix it. So this is our node 1. This is our node 2 and let's wait for this to come up. Okay, few services are not working. So we got a chance to talk about these services. So this is the right time to talk about these services. CMAN is the base service which enables the communication between the nodes. So this is the base service. RG Manager is responsible for managing services in the cluster. RHEL, as I already discussed, right? RHEL is a client service which actually make the changes in the cluster. So if you're going to update anything in the cluster, RHEL is the service which is going to communicate the changes across the cluster. Mod cluster D, it's actually check the cluster status. CLVMD, it's a cluster enabled LVM. So RG Manager, CMAN sits on the base, then CLVMD, and then top of it RG Manager. These two services are related but not in the stack. RHEL for making the changes in the cluster, it's going to propagate that change across the cluster. If you're going to use some command or some tool, mod cluster is actually check the status of the cluster. So in node 2, CMAN is not working, which is not good. So service CMAN, first of all check config --list off, it should be on. Check config -list RG manager. This is also coming off. I'm not sure why. Great. So service cman stopped. Oops, it shows saying that it's not able to find anything inside etc cluster. Cluster conf is not available. No issues. Install another package known as CCS. CCS is a command line tool. So if you don't want to use manager, you can use the CCS command line tool. It has all the features what manager has. So if you want to go with command line, use CCS. So what I'm going to do, I'm going to use CCS -h node1 -sync -activate. It's asking for my node1 password, that is my RHEL password. Done. So service cman start, starting. Great. So check config -list clvmd, it's also off. So clvmd on. We're going to talk about CLVM in later section, not right now. Service clvmd start. Service RG manager start. So now if I click somewhere else, come back and click here, and both the nodes are healthy. Great. Node 1 and Node 2, all the services are running and everything is fine. So what is exactly this cluster.conf? If you open this file, it's just an XML file, okay? So you can see this is the second version. First version created by the manager, second version created by the CSS command line tool. This is the name of the cluster. These are the nodes, node 1 and node 2 with node ID. This is a special, you can say special line for two node cluster. To keep your cluster correlated or to keep the quorum in the cluster, you need enough amount of votes. So the formula or the algorithm is n divided by 2 plus 1. But when you have two node cluster, n divided by 2 plus 1 doesn't work. So you have to put something like this: cman expected vote 1. Even one node is up in the cluster, it should work. And this is the special feature: 2 node equals to 1, which tell the cluster this is a 2 node, which tell the cluster service that this is a 2 node cluster. So cluestat is the command line or tool, or it's a command by which you can check the status. So you can see here the cluster status for this is the cluster name, and the status is correlated, means it has enough number of votes to run. Okay, so the next section is fence. Okay, so before going into this section, we need to install few more packages. That is yum search Linux, because this fence, because Linux is enabled on this on these machines. If you see, get sorry, get enforce is enforcing. So Linux is up. I don't want to disable it. That's not a good way to do it. So I'm going to install yum-y install few packages. That is first the core policy utils. So this one, policy core utils, I'm going to install this one. Then troubleshoot, troubleshoot server. Let me see. If anything else required, policy core utils. And this one as well. These are many packages it's going to install. Same packages I'm going to install here. Okay, so while it's installing packages, we're going to talk about what exactly the fence is. Okay, so let's go ahead and talk about fencing. Let me pull up the PPT again. Okay, so in single term, fencing means stop other node to accessing the resource. Let me give you a situation. In a cluster, suppose this two node cluster, node 2 and node 1 is communicating through this cluster channel. They are sharing their health status, and due to some reason now node 2 is not anymore able to contact node 1. Okay, so for node 2, node 1 is dead, and now node 1 want to access the resource of, or access the cluster resource of node 1. But there is a small problem. How node 2 will make sure that node 1 is not accessing the resource anymore? Suppose an ext3 file system is hosted by node 1. Inside this resource there is an ext3 file system. Now ext3 file system is not meant to mount more than one system. So in that case you cannot parallelly mount the ext3 file system on two nodes. If you do, there will be a high chance of data corruption. So node 2 has to make has to make a way to figure it out that node 1 is not accessing the ext3 file system anymore. And the easiest and the safest way is to power recycle the node 1. Once you do the power recycle, there is no way that node 1 can access that file system anymore. Okay, so to do a power recycle, you need some special kind of device or software. So if you go for a physical device, you can get these the diagram you can see, these are physical devices available. There are many kinds of devices available, ACP, Cisco UCS, even you can use Dell or HP ILO. For VMware, VMware SOAP is available. For KVM, you can use a virtual command or something like that. So there are tools by which you can reboot a node in a cluster. So what this fence device is actually, it's a piece of hardware in this diagram. So it's a piece of hardware, and all the nodes in the cluster are actually depending on this device for their power supply. This device also have an Ethernet connection and a terminal. So you can supply a command inside this device to power recycle a particular, you can say particular port, and in turn that will recycle the particular server which is connected to that port. So in that way it will reboot that particular server. So by this PPT, let me give you an example. Node 1 and Node 2 is communicating through this cluster channel, and due to some reason Node 2 is not able to communicate with Node 1 anymore. Maybe there is a high load on that Node 1 server, or something went wrong. Okay, now Node 2 has the responsibility to take the resources out of Node 1. Now, as I told earlier, Node 1 has an ext3 file system, so they should, what Node 2 have to do? It have to reboot. So it will send a command to the fence device, hey, could you please go ahead and reboot the Node 1, and the fence device will reboot the Node 1 by doing a power recycle. Once it's done, Node 2 can take the resources of Node 1. This is the safest way, and that's why we need a fence device in the cluster to make sure that there isn't any data corruption. In our Red Hat High Availability tool, if you click Add, you can see there are many fence instances are available. What is this? Actually, these fence instances are a piece of script, or you can say software or script by which you can send those commands to this particular device. Like in ACP power switch, there's a script for ACP power switch which has some parameters available. So you need to send those parameters to this ACP switch, and the ACP power switch will reboot the node. Like that, it ships with many you can say fence instance or fence device scripts. So for VMware, you have VMware SOAP. For here you can say RHEL, that is Red Hat Enterprise Virtualization. For that also it is available. But the one I am looking for is virch_fence, which is not here actually, because it is not supported. That is an experimental script, and it is not here available. The reason being it's not available because I am using a Ubuntu machine, and Ubuntu is not using what you can say like the agent by default ships with Red Hat. It is not available on Ubuntu. So I have to go with that experimental fence agent. Let me pull up the node, one of the node. I can show you. If you type fence and do a couple of tabs, you can see all this available, right? Fence act, this is one of the fence instance, or you can say fence agent. And the one I am looking for is fence_wish. Okay, this is the one which is available and supported, but this is only works on Red Hat, because Red Hat or Red Hat derivatives operating systems ships with a particular service which can be used by this agent. But in Ubuntu or any other Linux, you will not find that one. That is, you can say like custom or proprietary, not proprietary, but that is actually custom for Red Hat derivatives. But this one actually ships with Red Hat but not supported, but you can use for your lab purpose or for your study purpose, and this will work with any kind of Linux, even on Red Hat. So because this is not available in the manager, we have to depend on command line. It's not a very complex command, it's a small command. But before that, I want to show you something. As I told you that you need to supply some parameters or some arguments with that fence agent. So if you do fence underscore virch or -h, if you put, you can see all the available parameters. So -a is for IP, -l for user, -p for password, n for physical plug ID. When I say plug ID, if you remember from this PPT image, these are the plugs. So every agent will have one plug ID. Okay, no matter whatever fence agent you are using, you have to supply the plug ID. We are using KVM and there is no plug ID, there will be an UUID, or you can say that name of the machine. So if I pull my fence, these are my plug ID, node 1 and node 2. If you remember in the beginning of this tutorial, I told you that you need to keep the node name similar to the KVM machine as well as inside the operating system. The reason being, I have told you that synchronize the name across the board. So you have the same name inside the machine and you have the same name on the KVM. So that makes things easier. We are going to use identify file, this one. We are not going to use password because that's not a good way to keep password. Even for lab testing, it's not a good way to keep password. So we are going to use SSH keyless authentication. So for that, first I have to generate the SSH key. SSH-keygen, it already exists, just override it. Okay, and now we can do SSH-copy ID -I/root .ssh id_rsa.pub. This is the public file into the base machine, which is my KVM host. Username 192.168.1.200. So username at the rate of the IP address of my base machine. It's going to ask me for the password, just put it, and I now try to log in without password to check whether passwordless authentication is working or not. So I'm not going to type all the things, so just copy it, SSH, and this is working. So same thing we need to do on node 2. So SSH-keygen, yes, override. Okay, and SSH-copy ID -I, this is the pub file, and this machine, the base machine, 200 with the password. Great. So SSH, great. So passwordless authentication is working fine. That's the one thing. Now the second thing is to make sure that SE-Linux rules are in place for your fencing. So get sebool -a and grep for fence. So these two are off, so we have to say set sebool -P for this with 1. So this will enable the policy and my fence can do or my fence can connect through network and through SSH as well. So for both I have to enable. This first one will enable my fence agent to use network, and the other one will allow my agent to use SSH. So let's make the policy on both the nodes. Okay, so this one is done. Let's enable the other one. This is always take time, no matter how fast machine you have. But it's a good idea to keep SE-Linux up and running. This is an extra layer of security, and SE-Linux is no more pain. It's very helpful, and that's the reason I have installed all the SLNX troubleshooting tool. If something is getting blocked even after enabling this all things, all policies, you can get a very neat message in your var log messages, which will tell you what are the steps you need to take to enable that particular thing or particular service, which is very handy. Okay, so let's go back to the fence agent, which is fence underscore verse. We are going to do a dry run to figure it out whether everything is working fine before putting this agent into the cluster. So fence underscore verse hyphen a 192.168.1.200. This is my base machine, KVM machine, and this is the machine responsible for rebooting nodes or cluster servers. Hyphen L, the username, hyphen K, and that is ID, root slash dot SSH, ID underscore RSA, not pub, this is private key, not the public key. So you have to use here the private key. Then hyphen O status, I don't want to reboot, I just want to test it, and hyphen N node 2. So what I'm saying here to the fence agent, that log into this device 192.168.1.200 with the username this, and the file name should be, or you can say the identity file will be this, hyphen O, just get me the status of node 2. Let's head enter and see. Oh yeah, it's working. So it's saying the node 2 is up and running. Let me pull up my KVM. Yes, here it is. So you can see, yep, node 2 is running. Let's run the same command on node 2 and figure it out whether node 1 is running or not. That will make sure that both the nodes are able to use the fence device. Yes, so both the nodes are able to figure it out the status of each other, which means we are ready to move forward. So now we have to use this fence agent in our cluster. So we are going to use command line, as it is not available on cluster manager. So for doing so, we have to use the CCS command line tool, and the parameters I'm going to use is CCS hyphen H node 1 hyphen add fence def. Okay, just give it a name. So fence underscore verse. The agent name is fence underscore verse. I'm giving the same name, just the name of the instance is fence underscore verse. So you can give any name of your choice. IP address, IP ADDR 192.168.1.200. Login name, and the identity file, and that is root slash dot SSH slash ID underscore RSA, not the pub, the private key, not the public key. And action will be reboot. You can use shutdown also, but in most of the cases we need to reboot the box rather than shutting down. But you may get a situation where you want to shut down, so here you can put shutdown, but I want to reboot. So let me check it again, the syntax: CCS -H node 1 add fence dev the name of the fence instance, the agent IP address, username, identity key file, and the action. Looks good. Hit enter. Okay, let's validate that everything is fine. Sorry, ccs underscore config underscore validate. Yes, everything is fine. So now we can sync the configuration across the board or across the cluster. So ccs hyphen h node 1 hyphen hyphen sync hyphen hyphen activate. Once we do that, we can go back to our manager. Did it sync properly? Okay. So if you go back to manager, click somewhere else. Oh, session timeout. No issues. Just log in back. Click on fence device. And now you can see this, right? The agent type is Wish Fence Agent. Although it's not supported, but that agent has shipped with Red Hat operating system. So if you use command line, and after that if you come here, you can see it. So now what we have to do, and before that I want to show you what exactly inside that. We click on this fence agent, you can see all the parameters, right? That IP address, host name, login name, and so on and so forth. Okay, and other things are also there, but this much of information is enough. So click on the node. Now here you have to add the fence instance in each of the node. So you have to add the fence method. So I'm going to give kvm underscore fence. Just click on submit. You can give any name of your choice. And then add the fence instance. You can add more than one fence instance. You can have more than one fence device. Okay. The domain name will be node1. Rest of the thing just leave it. And click on submit. Great. Same thing you have to repeat on node 2. Add fence method. It's a good idea to give the same name. Okay. Add fence instance for node 2. Okay, so we are done. So we have added the fence instance and added that fence instance in both the nodes. So what will happen if node 1 want to reboot node 2, it's going to use this fence instance. If you open the configuration file, you can see this is the fence device or fence instance. And here you can see in both the nodes you have that instance, or you can say like both the nodes know how to reboot each other. So if node 2 want to reboot node 1, it's going to use this, okay, which in turn will call this fence instance. It's very simple. I will not recommend to edit this file through a VI or by hand if you are not an expert. This is an XML thing, and a single space or single comma can completely destroy your cluster. So don't edit it by hand unless you are very much aware what exactly you are doing. Use either your manager or command line tool. On almost you can say every time you just validate by using this command. So that will make sure that everything is fine. If something is wrong, it will give you a proper error message. So let's go ahead and run one command. This is my node 2. Let me make it big enough so you can see. I'm going to use command to reboot this node. So that is fence underscore node 2. This will make sure the configuration inside the cluster is working. Okay, I'm not using that fence script anymore. I'm calling my cluster service, or I'm asking my cluster service to reboot this node. So let's hit enter, and here we go. This is rebooted. That means my cluster configuration is working properly. One more thing I want to show you, that is when this node is going to reboot, it's going to join the cluster, you can say going to join the fence domain. You can see the message. So the PPT I have showed you, and I told you this is all known as fence domain. You can see that logical domain over here. It's going to join the fence domain, which means it's going to join the fence domain of node 1. You can see here, right? Joining fence domain. Great. So it has joined the fence domain. So fencing is working. Now let's talk about failover domain. What failover domain actually means, in a cluster you can have maximum of 16 nodes. Okay, so let's take an example. I have 5 nodes in my cluster and I have one service. I don't want this service to run on all the nodes. I want this service to run on specific nodes, because this service is very much resource hungry. So it's not feasible to run in all the nodes. I just want to run on specific node. Out of 5, I want the service to run on 3 nodes. So for that, I have to make a failover domain, which is a logical domain, which will restrict this service to run on only these 3 selective nodes. On top of that, I can make some rules like how to prioritize those 3 nodes, which one to choose first and which one to choose second and which one to choose last, and how to behave on those nodes. So let me tell you how to do it. Let me show you. Just give it a name. I'm giving site 1. Prioritized, I'm going to prioritize the node. Restricted, only run on specific node. No failback. This means do not send the service back to the previous node. Suppose I have 2 nodes or 3 nodes, okay? Let's take an example of 2 nodes. The service is down on one node because that server is, or the node is not working, okay? And my service has failed over to the second node. The moment that particular node or node 1 will come up into the cluster, the service will try to go back to the node 1. Okay? Now take an example of database. Database takes time to shut down, right? And it takes time to start also. So suppose in the middle of the day, when business was very high, because of high load, my node 1 went out of the cluster. So whole database has came to node 2. Now after half an hour or so, node 1 came back into the cluster. Okay. The moment node 1 will come back to the cluster, my service will try to go back to the node 1 because I haven't selected no failback option. That means again I'm going to hit a downtime of 15 to 20 minutes in the middle of the day. That's not a good idea. So if I select this, the service will not go back by itself. That means I have to throw it back, or I have to send it back manually. In most of the cases, it is fine. Now when I select this, I'm restricting it. The second option, I'm restricting the service to run only on these 2 selective nodes. Priority, I can give any priority, a positive number 1 from starting from 1 to 65, 535 works here. Lower the number, higher the priority. That's the Unix way. So prioritized it, restricted it, and no failback. So if a service moves to node 2, it will remain there or stay there until unless I manually fail it over to node 1 or send it back to node 1. Just hit on create. Okay, so let's again see the cluster config. want you guys to familiarize with cluster config. So you can see here, right? Failover domains, only one failover domain, site 1, no failback, ordered, restricted, right? Priority is here. So you can see it is prioritized. Cool. What else? So the next section is resource. Okay, so before moving to this section, I want to talk about a little bit about CLVMD. CLVMD is just like your LVM, or you can say like the native LVM. But in native LVM, what happens, your server keeps all the LVM related data in the local file system. It doesn't share with the other node. But when you do a CLVM, or when you use a CLVM, your node share that information with all the nodes available in the cluster. So it's actually not keeping that particular information with itself, it's sharing that information with other nodes in the cluster. Why we need that? In this way, other nodes will be aware on which particular you can say VG or LV your node is working. So node 2 will be aware on which VG node 1 is working. So before capturing that particular VG, it will make sure that node 1 should not have any locks on that VG. Okay, so there's another, you can say, piece of security. So to enable CLVM, first do VGS, and you can't see over here a C. If in this particular position, if you can see a C, which is this C, that means this particular VG is cluster aware. So first thing, you have to make sure that in your etc lvm.conf file, locking underscore type should be 3. Yeah. So if you go a little bit up, you can see here built-in cluster locking. Just make sure the same thing on node 2. If that parameter is not available or not enabled, you have to enable it. You have to make it 3. By default it will be 1 or 2, but the moment you install CLVM service, it changed itself to 3. That means the Red Hat High Availability add-on suite make the changes for you. But you have to make sure, you have to just double check it. Locking underscore type, that should be 3. Sorry. Locking underscore type. Yes. So both the nodes having the locking underscore type variable set or parameter set for 3. So VGS, VG change -AY, all are active, and CY with this. So now if I do VGS, you can see here, right? This attribute get changed from nothing to C. Here also it will happen by itself, because both the nodes are aware of CLVM. So if you enable it in one node, this is going to enable in all the nodes in the cluster. Now that means nodes are sharing the information to each other, which is a good thing. And this all happens with the help of a service known as DLM, Distributed Lock Manager, which makes sure that two nodes are not accessing a single file instance, or you can say like a single VG or single LV, not VG, single LV, which is another you can say another layer of security. It's actually secure your metadata, which is a very good idea. Great. So before going further, let me double check everything. /www/cgi bin. Oh, this is empty. So scp/var/www.cgi CGI bin host name into node 2 slash var www CGI. Great. And ls slash dev slash vg site1 is available. ls slash dev slash vg. Yes. Okay, so all the resources are available and we can put all the resources into the cluster. So what are the resources we have to put? First we have to put an IP address for the website or the web resource. So we're going to add, oh, we are in the wrong place, sorry. Add, click on add and use IP address. Where is that? There it is. Give it an IP address 192.168.1.20. Net mask not required. Disable update static route not required. Number of seconds to sleep after removing an IP 10 seconds works for me. So this is pretty much fine. I can use it. Great. Click on add again. The next resource I'm going to use is file system. So hit on file system. Name of the file system, web root site1, correct. Mount point slash var slash www html. I need to check what is that. That is dev slash vg underscore web lv underscore site. So this is the one. Let me cross check. Yeah. Great. Leave the mount option. File system ID is also not required. Force you mount, force FSCK. Reboot the node if a mount failed. Great. Click on submit. Again hit on add, and now we are going to add the service. So that is not the Apache service, that will be script, which is system v script. Just give it a name, httpd, and the path of the script, that is etc init.d/httpd. Hit on submit. So now if you open cluster.conf, you can see the resources has came in. IP address, file system, and the Apache service or HTTPD service. Great. What else? Now we have to make a service group and add those services here. So we have put it the nodes, we have put it the fence devices, we have made a failover domain, we have added the resources. Now these resources will go inside a service group. That's why I was having that container shape over there in my PPT. This is a service group. Okay, that's why I have put a container there. So let's click on service group. Add a service group. Just give it a name. I'm giving site1. Automatically start this service. Yes. Run exclusively. This option, if you use this option, what it will do, if this service group is running on a particular node in the cluster, no other service group can run on that node, or can stay on that node. So it will make sure that only this service group is running. We need this thing when you have a very bulky application or very huge database which is very much resource consuming. So in that case, you want to make sure that if this particular service migrates on any node, there shouldn't be any other service running. So in that case, you have to use this one, run exclusively. Failover domain, site1, that's our domain. Recovery policy, how you want to recover. Restart will try to restart that service on that particular node itself. Disable, don't do anything, just disable it. I'm going to use relocate and click on submit. Parallelly, I'm going to show you what happens on the cluster conf. So here you can see a service domain is there, right? But there is no resource inside that. So we're going to add the resources. Add the resource. Sorry, I am clicking on the wrong thing. Here I have to click site 1. Okay, so add the resource. First, IP address. I want the IP address should come first, okay, because that is the thing, that is the point from where I'm going to access my service or my website. Then I'm going to add a child resource. If IP address come up properly, after that, go ahead and mount the file system. If IP address is not there, there is no point to add the file system, right, or mount the file system. When file system is mounted cleanly, then go ahead and start the service. So there is a parent-child relationship. So first IP address has to come, then file system has to mount properly, then start the service, which makes much of sense. Click on submit. Meanwhile it's doing that, let's take a look on the cluster conf. Now you can see here, under resources, these are the resources, and under domain, service domain, or you can say like service, site 1, this is how it is. First IP address, then your file system, and then your service, right? That this is you can say alias, and this is the definition. So when I say IP, this is the IP details or parameters. When I say web root, this is the web root, right? And when I say HTTPD, this is the script name. So these are the alias for these resources. So let's go back to manager. And it is running on node 2. Okay, so BlueStat showing me, oh, it's not showing. It's saying it's running on node 2. So let me go to the node 2 and check. Sometimes it doesn't come up properly. It's showing in node 2, but node 1 is not aware of that. Let me check the logs. It's showing that it tried to start the service, but that is not working. Let's check on node 1 why. This is a good point for troubleshooting it. Okay. We'll make sure all the file system and everything is available. File system is mounted. And IP address also came in, and service is also running. Let's go ahead and try to migrate into node 1 and figure it out why that is not getting started on node 1. So the command is clue svcadm -r for relocate, and the relocate the service, or you can say service group, that is site 1. On the member node 1, we'll go to node 1 and let's tail -f var log messages to figure out what's wrong with this guy. Hmm. Gosh. Okay, let's check here. Saying like unmounting was uploaded to HTML, removing the IP address, site 1 is stopped, failed to relocate, restarting locally. Okay, let's go to node 1 and try this command. usvcadm hyphen r site 1 hyphen m node 1. Oh, service RGM manager status. Oh, RG manager is dead. Okay, no issues. Let's do one thing. Fence 1. I'm going to reboot the node 1. Although I can start that RG manager and do everything, but that section I have kept for troubleshooting. So I don't want to show all those things. There will be a different section for troubleshooting. So we'll go and do the T-shoot. Right now I don't want to show you all those things. In this section we will see how to bring that service in cluster and access it. So let's see what node 1 is doing. Node 1 is almost up. It will come back cleanly. Okay, node 1 has came up. So service RG manager status, sorry, MANAGER is running. Close that. Okay, so clue svcadm hyphen r site 1 hyphen m node 1. And if I go here and type cluestat hyphen I in interactive mode every second, you can see it stopped here, and very soon it's going to start on node 1. Starting, wait, started. So if I come here and type again the same command, it started on node 1. You can see here, right? Great. So if I go ahead and I'm going to use my Firefox browser. It's currently coming up. So the IP address is 192.168.1.20. Hit enter, and the service is running on node 1, right? Great. I'm going to show you the failover. What happens when you do a failover? So this is for node 1. And this is node 2. So this is my website, this is node 1 and this is node 2. So on node 2 put cluestat hyphen I1. So it will check the status. On node 1 I'm going to put the same command with node 2 and hit enter. I'm going to stop it on node 1. Going to start it. As you can see, it started searching where the website is. Stopping on node 1. Now move to node 2, starting on node 2, and now started on node 2. And you can see here, from node 1 it went to node 2. That means everything is working fine. My resources is moving from one node to another without having any problem. So in this whole session we have configured fence, we have configured the failover domain, we have configured resources, and we have configured the resource group. In next session, we are going to configure quorum. I'm going to show you how to troubleshoot it, how to figure it out everything is working properly before putting into the production, and few more things that you need to keep in mind when you are playing with this tool. I'm Sandeep. Thank you for watching this part of the video. I'm going to see you in the next tutorial section. Thank you.